You have heard about MCP servers, but have you ever built one? No? Let's build one then. We need surprisingly little code to implement an MCP server. Let's use Semaphore for example. We have a detailed API that exposes anything you might ever need to know about your CI/CD, your continuous integration, your workflows, your jobs, anything. So first we need an API token, so I will create one service account here with admin access to my Semaphore organization. I want to keep things simple, so I will only list the projects that exist in my organization. I can get all my projects using this query. When we prettify this JSON, we get something like this. We are really interested in the metadata and especially in the name. So we want the names of every project in my organization. Let's create a new project called Semaphore MCP and go inside and create a virtual environment and we'll activate it. Now we are going to need two dependencies, HTTPX and MCP CLI. Let's start by importing the operating system and then our two dependencies, MCP and HTTPX. And we are going to initialize the MCP server with fast MCP and give it a name. Next, we're going to define our tool. This is a function, and we are going to use the decorator mcp.tool. We are also going to define with type hints what is the return values from this function. In this case, is a list of dicts. We're going to access our secrets, the API token, and the name of the organization from the environment variables and construct the HTTP request for the API. And finally, we are going to make a GET request using the URL and pass the authorization token and a timeout. We're going to return only the metadata name for each of the projects in the response. Main starts the MCP server, and the transport method in this case is standard input output. This allows us to communicate using text, using standard input and standard output to communicate between the MCP server and the MCP client, which in this case will be the AI. And finally, we start main when we execute main.py. Now, since we're using standard input output as the communication between the MCP server and the AI, anything that the function, the tool returns is going to be transformed into text and is going to be processed as standard input by our LLM. Now, to test this code, we can use the OpenAI's debugger. We can call it with npx, and we pass all the parameters required to execute the program here. And this is going to open a session and open a browser with the tools to debug my application. Now, this will open the debugger in the browser, and you can see that has been pre-populated with all the required arguments to run the application. The only thing that I have added here is the Semaphore API token and the Semaphore org. This will allow my server to connect my organization and pull the data. Now we only need to connect. We are going to go to tools and list tools. This shows us the function list projects, and we have also here the output schema. This is all extrapolated from the docstring and the type hints from my function in main.py. Now if we press run tool, we're going to get all the names of all my projects in my organization, and we also get a valid message, so the tool is working. The next step is to register this tool for our agent. I'm using Codex this time, so I'm going to show you how to add this MCP server to Codex. Now to register the tool, we are going to use Codex MCP. We can use list to see the servers that are registered. I have already one created here, and to add our MCP server, we're going to use this command, mcp at semaphore, pass the environment variables, which are already loaded in my shell, and then the command with the directory to run the application. And now we should see that MCP server is registered. So now I can start Codex, and I can ask it about my project. I can ask it to list the project I have in my organization. It's going to use the tool list project, and it's going to give me a nice list of all the projects I have. I could extend this MCP server to list everything, my workflows, my pipelines, my jobs, my job logs, to see the errors, to detect flaky tests or deployments. If I can extract the logs from failed jobs, I can ask my Codex agent to fix that and to push a fix into the repository. Having an MCP server right into your pipeline, into your continuous integration system, changes everything. You don't have to switch context to see how your pipelines are doing, if any test or job have failed. You can stay in your IDE or your terminal and get that information right using the MCP server, This is of course more of an educational thing. This is not production code, but the good news is that we are creating an actual official MCP server for Semaphore. So every Semaphore user will be able to connect to do the MCP server and interact with your pipelines and jobs using your favorite agent or IDE. That's all for today. If you like this video, please like, and why not subscribe, since we're going to do a lot more content on MCP and AI in the future. Thank you for watching, and see you on the next one.